So we have the quadratic inequalities like with many parts, but not exactly quadratic. But since they are given us as parentheses, the parts inside the parentheses can be solved as quadratic equations. We have these questions solved in the class. I'm going to resolve 1-2 of them. This question, let's do that. So these are all in the terms of like times and times and times. Firstly, you find the critical points that we call makes it equal to 0. So x minus 1, the first part equals 0 when x equals 1. And then the second one, x minus 3 equals 0 when x equals x minus 2 in here, sorry, when x equals 2. Then x minus 3 equals 0 when x equals 3. When x minus 4 equals 0, x is equal to 4. From these ones, we have this special case. Over the parentheses, if you have some powers, you should check them. The even powers, we call them as double root. When it's double root, it doesn't change the sign when we prepare the sign chart. So then after finding the critical points, we prepare the sign chart and we be careful about the double root. X, all the x numbers which makes this whole expression equal to 0 from minus infinity to the plus infinity. The critical points 1, 2, 3, and 4. The double roots, we show them with double line. So when we prepare the sign chart, that's going to help us. So then the whole expression, the all expression in here, I forgot to do this. The sign to start with, that's also important. So you check the sign of the biggest, like the biggest x value inside every parenthesis. We have 1, 2, 3, 4 parentheses. Check the sign of the biggest x value, x with power, biggest degree, we can say. So it's 1 times x, so it's a positive. This is 1 times x is positive. This is 1 times x is positive. This is 1 times x is positive. Right now I am looking for which sign to start with. So you check the signs inside every parenthesis and you multiply them. The result is positive. So you start with plus, then every root you change the sign. From plus to minus, the double root doesn't change the sign. Single root changes the sign. Double root doesn't change the sign. So then it is time to choose the intervals. So the whole expression that I want to solve, so I'm reading this from left to right. All of them must be smaller or bigger than 0. Since we see the open part first, it should be bigger than 0. So bigger than 0 means positive parts, and positive parts. Can I include the ones which makes it equal to 0? Bigger than or equal to 0? We can include the numbers which makes it equal to 0. So right now I'm writing the intervals. X element from minus infinity to minus 1 included and to 2. So I don't have to write them separately because 1 itself is also included in this interval. So I can write that from minus infinity until the number 2, and the number 2 is also included. After number 2, what is the next answer? It's only the number 3 between here. We cannot use the other intervals. So we use union with set parentheses only the number 3, then union, then we have another interval with this kind of parentheses. So from 4 to plus infinite, all the real numbers can be used as answer. So now one more question I want to show you about this case. So in this question, check that we have no powers over the parentheses. So we don't need to care about that anymore. So first thing we look for each part equals to 0. 3 minus x equals 0 when 3 equals x. Then x squared minus 2x minus 8 equals 0. Then x squared minus 9 equals 0. I find the critical points from every parentheses. So I need to factorize this. 2 times 4 minus goes to big 1, and it will be plus 2. X plus 2x minus 4 equals 0. And x equals minus 2, and x equals plus 4. And in here, we can do this as a squared minus b squared. This is 3 squared. This is x squared. So it is x minus 3 and x plus 3. We can factorize that equals 0. There will be two answers. X equals 3, x equals minus 3. So then I'm going to show all of these critical points for the whole expression from minus infinite to the plus infinite. So I'm going to draw a line for 3. Let's do it in here. I'm going to draw a line for minus 2. It should be before minus 3. Draw a line for 4, number 4.
Teacher, it's minus 2.
Minus 2, sorry. Okay, come on. Draw a line for 3. So it was already drawn. So I'm going to draw another in here. So this is again a case like we call double root. If you find the same answer from two different places, you have to draw 2 lines for it. So this is also double root. And a number for minus 3, which a line for minus 3 at the end, we should draw. Also, you can see this as, check that, if I write all the factorized parts one by one, this 3 minus x, it can be written as minus times x minus 3. And here we have another x minus 3 as product. So it becomes x minus 3 squared. That's why we call this as double root. This part, 3 minus x, if you move the minus out of the parentheses. Anyway, it's not the real case. Just know that if you happen to find, if you find the same number twice, so you should draw 2 lines, that makes it double root. Then which sign to start with in here? I'm looking for that right now. So in the beginning, I multiplied the 3 parentheses. Inside this parenthesis, what is the biggest x value? In here. So the sign of it, minus, times the biggest x value in here, the sign of it, plus, the biggest x value, the sign of it, plus. When you multiply the 3 signs in here, you will get minus, so you should start with minus. So then you continue as minus changes plus, you don't change, changes to minus, changes to plus. Then final answer. We want this whole expression to be, read from left to the right, to be smaller than 0. That means I need negative parts. I need negative parts. Can I include the numbers which makes it equal to 0? So no equal here. So I cannot include any of these numbers in solution. So x element. From minus 3 to minus 2, all the real numbers, minus 3 to minus 2, sorry, minus 3 comes first. So in this case, we use this kind of parentheses to show that minus 3 and minus 2 not included. And union, we have another interval from 4 to plus infinite.